Hello everyone, this is Team Codebot. This is Vinayak Sharma, and with my teammates per single, we made a natural language processing (RAG) integrated tool to summarize and generate accurate code bases. So let's get started. To start off the project, we use a Python script to generate the code files in a JSON format. So to start it, we run this command, and after some times it generates all the related code files in this JSON format with the number of keys which are made. So these are the file name, path name, and the code block in that file. We also add a rank based on how much deeper in the directory it is. So these are all the code files. And then we start off the Docker compose. So these are all the containers which are running. Now let's get started into loading the content. So for loading the data, we use the loader file, and it is running on 8502 host. And then we just click on import. So it starts the loading up process of the data and queries using Cypher language into Neo project. So since this is a large file, it takes a bit of time to load up. So we see around 600 nodes are inserted. It is still going on. To insert the data, we use these three queries, and to generate the page, we are using Streamlit. Mm, This depends on how large the project is also. Since our project is Rocket Chat, and you can see it's quite a big project which has directories in directories. So this project is especially for those large projects which are really difficult for beginners or any organization to keep track of. These are some of the properties which are inserted. This is the current knowledge graph which is formed. It has many files which are integrated with the keys in the file. This contains is the relation which shows if any code block is inside a particular file. So I think most of the content, yeah, it's successfully loaded. So now is the time to generate the answers using origin. So for this we have a sample prompt. Let me just copy that from you. So this is one of the sample file in the rocket chat project. So now we'll wait for it to generate. So if we can see here, this project has generated some embeddings for the core tokens. Since it's a large project, a lot of embeddings and their values are generated. We can also customize how much in depth we want to go. We can reduce or increase the token numbers. Currently, I have set it to 10,000. This solution is much more feasible for an enterprise or an on-premise solution, which like have a large computer specification. Since my laptop is not much supported for this, it's taking some time for the generation. In the meantime, let's see how well the ChatGPT works with this. We can see it like it's much more vague and not much specific. So now our RAG application has started generating. So let's wait some time for it to generate. So this was the result after computing, I think. And the best part of the application is the whole application is Dockerized. So like we can just start up the application with one command. Let's check how much the compute is taking up. So we can say it's taking a lot of um, resources. So it's a resource intensive task. And for the generation we have used Code Llama LLM, and for embedding we have used sentence transform. So as we can see, it's giving much more accurate answers regarding the component structure. We can wait a bit long, but the video will become too long. So let's stop this application. So this is the result of the generation. Total time it took around 2,58,000 seconds, milliseconds. So yeah, and all the relationships are stored here. So this is a better solution than ChatGPT, and this can also be used by the contributors who are beginners and want to get started with a contribution but are afraid of the huge code bases. This can be used by them as a single point of truth to get all the answers and queries answered. This can also be used by the open source project maintainers to maintain a large code base and get updated about the changes happening at a large. So, thank you for your attention. That's all.